Hey guys, so I am back for a little while, and I'm going to tell you now about uniform circular motion. So this is a brand new chapter, okay? And yeah, I will be doing my videos. I will have a little bit of a pause next week because I have a surgery, but then I will be back, okay? So circular motion. First of all, we need to know what I mean when I say uniform circular motion. So uniform motion is anything that has a steady speed. Now, I'm not saying acceleration, or I'm not saying that the acceleration is zero, because as you will see later on, there is one acceleration that is going to take over the changing speed, while there is another acceleration that is going to take over the changing direction, okay? So its uniform motion means that the speed is steady, not the velocity, because velocity is a vector and it changes, okay? So the direction changes, so velocity changes, okay? Now, circular means that the direction changes, as I have been saying so far, so the object rotates, so the velocity changes, okay? Now, it's very easy to show that the speed v, and v is just what they normally use to talk about the speed when we're talking about circular motion, that is going to be 2 pi r over t, where r is the radius of the circular path. So even if you don't have a full circle, it's going to be the radius of the curve. And t, big T, not the same t that we use for time, big T is the time for one rotation. So if you want to show this, it's really easy. You just need to remember that the velocity is the distance covered over the time taken. This is something that you learn really early on. And the distance, when I have a circular motion, is going to be the circumference of my path, okay? I have here written wheel, but you know, any path. So that's going to be 2 pi r, and you should have it in meters, okay? So that's the units. And t is going to be the time taken for one rotation, and it's going to be in seconds. So because v is the distance covered over the time taken, v is going to be 2 pi r over t, okay? You may be even asked to show this. So questions in any exam can be as easy as show this formula, to demonstrate this formula, okay? Now, I can also talk about the frequency of my rotations. So if I do so, I use the symbol f, and f is going to be 1 over t, where t is the time taken for one rotation in seconds. That means that my frequency is going to go in hertz or in second minus 1. Now, just for you, a couple of exercises in case you want to try them, so you can simply just pause the video and try to answer these questions. So I have a cyclist that is traveling at a speed of 20 meters per second, 25 meters per second. Someone is trying to get into my room. On a bicycle, which has a wheel of a radius of 750 millimeters, sorry. So, time for one rotation, frequency of the rotation, and number of rotations in 1 minute. If you got the exercise right, you're going to have that the time for one rotation is going to be 0.19 seconds. Again, remember, you have the speeds, you have the radius, so you have everything that you need for the time for one rotation. Frequency, you need to do 1 over the time for one rotation, so that's going to give you 5.3 hertz, and then the number of rotations in 1 minute, so in 60 seconds, should be giving you, something like 320 if I'm giving you my answers in two significant figures, okay? Now, something else that you need to know is about angular displacement and angular speeds. Now, as you know, we are not talking about something that is linear. I'm not talking that I'm going straight on a line. I'm actually going to do some curved paths somehow, okay? So I can try to give you information about my path, which is curved, which is circular, by talking about the angles. So that's why I have the angular displacement and the angular speeds. So angular displacement is going to have the symbol theta, and is the angle that an object in a circular motion turns through, okay? And it comes in radians. So in each second, I am going to have the following angular displacement, which is 2 pi over t, the time for one rotation, in radians or rods, okay? So if I don't want to know in each second, but I want to know in any given time, t, small t, then my angular displacement will be 2 pi t divided by, so small t divided by the big T, the time of one rotation, the time period, okay? So it's the same as in 1 second, but I multiply it by the time t. Now, you already know that frequency is going to be 1 over t, the period or the time for one rotation. So in any given time, my angular displacement can be also be given with by the formula of 2 pi f, the frequency, times t, the time, and this comes in radians rad, okay? Now again, because I still have a speed, but I'm going around in a circular motion, I can talk in terms of angular speed, and that's going to be the rate of change of the angular displacement of an object in circular motion, which is the angular displacement per second. So it's just like the normal speed, but now taking in considerations that I'm going on a curve, okay? So the angular speed is going to be this symbol that looks like a W, but is actually an omega, and is going to be 2 pi over t, the time period, which will be 2 pi f, because the speed is going to be radians per second, or radians minus 1, or radian second minus 1, okay? So in general, in case you're feeling a little bit overwhelmed with the new information, note that anything that is circular follows this formula, okay? So you pick up the formulas that you know when you were talking in linear motion, so non-circular, and the linear is going to be equal to the circular motion times r, the radius of your curvature, okay? So for example, my linear velocity, or my linear speed really, is going to be equal to the angular speed times r, the circumference. If you want, one thing that you can do to understand this is either draw a circle, or then even, you know, just cut a rope and then just make it as a full circle. So make it that the two ends join together, okay? And that would be a circle, right? If you cut the two ends, so if you separate the two ends and you make them loose into one line alone, you're going to see that you have the same as the circle, but now with the radius that is going to be spread out, okay? So that's exactly the same thing. So if you know about linear motion, you will understand circular motion. Just to remember that linear is the circular times the r, okay? All right, some hints. Because you are going to be using radians, and you need to be careful in your calculators when you're doing these calculations, because again, it needs to be in radians, it's good to know as well how you convert from radians to degrees, okay? So a full circle, which is 360 degrees, is equal to 2 pi radians. So that means that half of a circle, 180 degrees, is pi radians. And a quarter of a circle, which is 90 degrees, is going to be pi over 2 radians, okay? So by following this, you can prove yourself that 1 radian is 57.3 degrees. If you want, you can simply just memorize this, and then you can convert from radians to degrees and degrees from radians as much as you want, okay? Another hint, so if you have a certain time and you have an object moving at a speed v, and you want to know, and is going through a certain distance s, that distance is going to be v times t, just like in linear motion, but because I'm going in circular motion, is going to be 2 pi r times t the time divided by big T the time period, which is going to be theta r, where theta is the angular displacement times r, the radius of the circumference, okay? So again, the displacement that you're going to have, the linear displacement, is equal to the circular times r, just like that formula that I showed you here, okay? So if you're feeling a little bit overwhelmed, make sure that you make a relationship between the linear that you already know with the circular by multiplying by r, okay? And the speed will be 2 pi r over t, t, the time period, which is going to be the omega r. So again, linear equals angular times r, okay? A study tip, the unit symbol for the radians is rods, so you need to make sure that you convert angles from degrees to radians, and remember to use rods for the angular displacement and rod per second for angular speeds. So if this is showing twice in 2 slides, you know this is important, okay? And this is just a visualization, okay? So you have r, the radius of the circumference, you have been moving a certain theta angle, and this s is going to show you how much you are moving your displacement, okay? Alright, so another exercise just for you to practice. Here's a picture of the London Eye, and it says it has a wheel with a diameter of 130 meters, and each rotation takes 30 minutes to complete. I remember when you would stay there for 40 minutes, but now it's going a little bit faster. Okay, so they want to know in degrees and in radians how much each capsule is going to turn in 450 seconds, 900 seconds, 1,350 seconds, and 1,800 seconds. Give it a go, pause the video, or if you want to know the answer straight away, here it is. So 90 degrees is going to be pi over 2 radians in 450 seconds, because that's going to be the 30 minutes divided by 4, okay? So that's going to be about 7 minutes and something. 180 degrees is pi radians in 900 seconds, so in 900 seconds it did half of the path already. 270 degrees, 3 pi over 2 radians, so that's how much it moves in 1,350, and the whole trip is going to be 360 degrees, which is 2 pi radians in 1,800 seconds. All right. Now this is something that you may want to pause, print screen, and print for you. So this is several degrees, and then the equivalent in radians, or the equivalent even if you want to think about slices of pi over something, okay? So that's something that is useful for you to have in your head in case you are finding this a little bit difficult. However, you don't have to memorize this by heart. You can simply just think about the conversion between degrees and radians, or just, you know, do it by yourself by thinking 90 degrees is going to be pi over 2, so how much is it going to be 60 degrees, okay? Now another worked example, and it's going to be the last one, and the solution will show as well. So they have another cyclist, 12 meters per second, and the radius of the wheels are 0.40 meters. They want to know the frequency of the rotation for the wheels. They want to know the angular speed of each of the wheels. They want to know the angle that the wheel turns in 0.10 seconds, in radians, and in degrees. Again, you can always pause the video, and then the answers are going to show in here, okay? So the circumference is going to be 2 pi r, so you do 2 pi times 0.4, that gives you 2.5 meters. The time for one rotation is going to be the circumference over the speed, so 2.5 divided by 12, so that's going to be 0.21 seconds. Therefore, the frequency is 1 over the time of one rotation, so 1 over 0.21, that gives you 4.8 hertz, or second minus 1. Always follow this stuff, these tiny steps when you're doing this in an exam, because if by any reason you get a number wrong here, if you typed in wrong in the calculator, you have the steps, so you have the thinking and you get awards, you get credits for the thinking, okay? The angular speed is going to be 2 pi over the time of one rotation, so that's going to be 2 pi over 0.21 seconds. That's going to give you 30, and then you need to put the units, so radians per second, or radians second minus 1. Then the angle that the wheel turns in 0.10 seconds. So that's going to be, using the angular displacement formula that I showed you before, 2 pi times t, the time that they want to know, over t, the time of one rotation. So that's 2 pi times 0.10, which is the time they are asking in the exercise, divided by 0.21. That's going to give you 3 radians. And then in degrees, you can just say that 3 radians is equal to 3 times 360, the number of degrees that you have over 2 pi radians, and that's going to give you, just two significant figures, 170 degrees, okay? I think that's it. Oh, there are more questions. So that's how you can do the questions, okay? And in this one, I'm not going to go step by step. I'm simply going to give you the questions in here so the video is not too long, okay? Give you the questions in here. You can always pause it, and then you can check against the solutions, okay? As always, any problems, you can come and find me directly, or if you do not have the pleasure of having me as your teacher, you can message me. Although, you know, of course, I don't know how long I can spend on YouTube answering messages, but yeah, you can give it a try. So take care. I'm hoping to make another video before my surgery. But if not, I'll see you once I recover, okay? So take care, and yeah, bye!